Welcome back to the Comptia Network Plus course, VLAN Hopping. VLANs or virtual LANs are layer 2 subdivisions of the ports in a single switch. A VLAN may also span multiple switches when devices are segregated into VLANs. Access control lists, ACLs, can be used in a router to control access between VLANs in the same way it is done between VLANs. When VLANs span switches, the connection between the switches is called a trunk line. It carries the traffic of multiple VLANs. Trunk lines are also used for the connection for the switch to the router. A VLAN hopping attack results in traffic from one VLAN being sent to the wrong VLAN. Normally this is prevented by the trunking protocol, a VLAN tag in the packet to identify the VLAN to which the traffic belongs. The attacker can circumvent this process by a process called double tagging, which is placing a fake VLAN tag into a packet along with the real tag. When the frame goes through multiple switches, the real tag is taken off by the first, leaving the fake tag. When the frame reaches the second switch, the fake tag is read by the frame, is sent to the VLAN in which the hacker intends the frame to go. The process is shown in figure 417. Attacker VLAN 1802.1Q trunk, switch 2 access VLAN 10 victim. Authentication issues. Since the process of authenticating a user or a device forms the basis for securing most resources, authentication issues can lead to improper access, stolen data, and a whole host of other problems. In the following sections we'll look at some of the most common authentication issues. TACACS radius misconfiguration. Terminal access controller access control system plus and remote access dial-in user service radius are both examples of authentication, authorization and accounting AAA serves that verify the identity of, grant access to and track the actions of users. Misconfiguration of these devices can result in an inability of users and devices to connect to the access devices that are clients of the AAA server, switches, WAPs, dial-up servers, VPN servers. Some of the most common mistakes that result in this situation prevent communication between the AAA server and the AAA client. When this happens, check the following. Verify the port numbers. Even if the standard port numbers for these services have been selected, that doesn't mean the product you are using uses these port numbers. Make sure the client and server are using the correct port numbers. Check to see if there is a mismatch in the pre-shared key between the client and the server. When the problem is an issue between the supplicant user or a device requesting access and the authentication server, switch, WAP, dial-up server, check the following. Verify that the AAA method configured for the supplicant lists the appropriate radius for TACACS server group. Verify the authentication port number matches the configured port number. Verify that the user is configured on the AAA server user account. Default password settings. All network devices are configured with default administrator accounts for their default passwords. These accounts should be disabled and renamed if possible. At the very least, the passwords for these accounts should be changed from the default because they are well known, available in documentation that comes with the product, and also widely available on the internet. Viruses. Viruses with catchy names like Chernobyl, Michelangelo, Melissa, I Love You, Lovebug are possibly the best known threats to your computer security because they get a lot of media coverage as they proliferate and cause tons of damage to legions of people in their simplest forms. Viruses are basically little programs that cause a variety of very bad things to happen to your computer, ranging from merely annoying to totally devastating. They can display a message, delete files, or even send huge amounts of meaningless data over the network to block legitimate messages. A key trait of viruses is that they can't replicate themselves to other computers or systems without a user doing something like opening an executable attachment in an email to propagate them. Figure 14.8 shows how fast a virus can spread through an email system. So here you can see, here's your figure 14.8, and here you see the user clicks on the attachment, I suppose, and a virus then replicates throughout the network. There are several different kinds of viruses, but the most popular ones are file viruses, macro, data file viruses, and boot sector viruses. Each type differs slightly in the way it works and how it infects your system. Predictably, many viruses attack popular applications like Microsoft Word, Excel, and PowerPoint because these programs are easy to use, so it's easy to create a virus for them. Unlike with the DOS attacks, writing a unique virus is considered a programming challenge. So the scoundrel who is able to come up with it not only gains respect from the hacking community, but also gets to bask in the glow of the media frenzy that results from their creation and relish their 15 minutes of fame. There is also a big reason why viruses are becoming more and more complex and harder to eliminate. Logic bomb. A logic bomb is a type of malware that executes when a particular event takes place. For example, that event could be the time of day or specific date, or it could be the first time you open notepad.exe. Some logic bombs execute when forensics are being undertaken, and in that case the bomb might delete all digital evidence. Ransomware. Ransomware is a class of malware that prevents or limits users from accessing their information or systems. In many cases, the data is encrypted and the decryption key is only made available to the user when the ransom has been paid. Effects of malware on the network. Malicious software or malware is a term that describes any software that harms a computer, deletes data, or takes actions the user did not authorize. This is a wide array of malware types, including ones you have probably heard of like viruses. Some types of malware require the assistance of a user to spread, while others do not. A worm is a type of malware that can spread without the assistance of a user. A worm is a small program like a virus. It is used to deliver a payload. One way to help mitigate the effects of worms is to place limits on sharing, writing, and executing programs. However, the real solution is to deploy antivirus and anti-malware software to all devices on the network. This software is designed to identify viruses, trojans, worms, and delete them, or at least quarantine them until they can be removed. File viruses. A file virus attacks executable application and system program files like those with file names ending in .com, .exe, and .dll. These viruses do their damage by replacing some or all of the target program's code with their own. Only when the compromised file is executed can the virus do its dirty work. First, it loads itself into memory and waits to infect other executables, propagating its destructive effects through a system or network. A couple of well-known file viruses are Jerusalem and Limba, the latter of which is actually an internet worm that infects common Windows files and other files with file name extensions like .html, .htm and .asp. Macroviruses. A macro is basically a script or commonly enacted commands used to automatically carry out tasks without requiring the user to initiate them. Some popular programs even give you the option of creating your own personal scripts to perform tasks you do repeatedly in a single step instead of having to enter the individual commands one by one. Similar to this, a macro virus uses something known as the Visual Basic macro scripting language to perform nasty things in data files created with programs like those in the Microsoft Office suite. Because the macros are so easy to write, they are really common and usually fairly harmless, but they can be super annoying. People frequently find them infecting the files they're working on in Microsoft Word and PowerPoint. Suddenly you can't save the file, even though the save function is working. You can't open a new document only template. As I said, these viruses won't crash your system, but can ruin your day. CAP and CAP are an example of macro viruses. Boot sector viruses. Boot sector viruses work their way into the master boot record. That's essentially the ground zero sector on your hard disk where applications aren't supposed to live. When a computer boots up, it checks this area to find a pointer for its operating system. Boot sector viruses overwrite your boot sector, making it appear as if there's no pointer to your operating system. You know you've got this type of virus when you power up the computer and get a missing operating system or no hard disk error found. Monkey Bee, Michelangelo, Stone and Stealth Boot are a few examples of boot sector viruses. Multipartite viruses. A multipartite virus is one that affects both the boot sector and files on your computer, making such a virus particularly dangerous and excessively difficult to remove. Figure 14.9 gives you the idea of how a multipartite virus works. You can see that it is attacking the boot sector, memory and the disk at once. So here you can see multiple viruses and it's affecting memory, disk files and the boot sector. Anthrax and Tequila are both multi-party viruses. These viruses are so nasty that you might end up reformatting your computer if you get one. The Anthrax virus was more of a hoax than a real virus. What is really interesting about the Tequila virus is that it does nothing until the next boot. It was no hoax. Although many software companies can handle these, the best way to save your computer a complete overhaul is to make sure you do not get a virus in the first place by using a good virus scan program as well as Windows Defender. Zero-day attacks. Antivirus uses definition files that identify known malware. These files must be updated frequently, but the update process can usually be automated so that it requires no help from the user. If a new virus is created that has not yet been identified in the list, you will not be protected until the virus definition is added to the new file is downloaded. The condition is known as a zero-day attack. It is the first day the virus has been released and there are no known fix exists. This term may also be applied to an operating system bug that has not been corrected. Insider threat, malicious employee. It is often said that an organization has the most to fear its own employees. They have already completed two phases of the hacking process, that is discovery and penetration. They are already inside your network and probably have learned quite a bit about the network just doing their job. The first step to mitigating damage may be caused by a disgruntled or malicious employee is to adhere to the principles of least privilege. This concept describes that users should be given only the resources required to do their job. Another principle that should be followed is called separation of duties. It calls for breaking up sensitive operations into two parts and having different users perform each part. This means there would have to be collusion between the two to take advantage of the process, which is not likely to occur. Finally, all network access should be taken from a user who has been terminated before they have a chance to access the network. Vulnerabilities. While malware certainly presents an ongoing danger to your network, it is not the only concern of the security professional. In the following sections, I'll cover other issues. Exploits and vulnerabilities. A vulnerability is the absence of a countermeasure or weakness in a countermeasure that is in place. Vulnerabilities can occur in software, hardware, or personnel. An example of vulnerability is unrestricted access to a folder on a computer. Most organizations implement a vulnerability assessment to identify vulnerabilities. An exploit occurs when a threat agent takes advantage of a vulnerability and uses it to advance an attack. Unnecessary running services. Services that are not required to be running on a system should be disabled. Running services present an additional attack surface to the hacker. Once they identify the running service on a machine, they will research all the vulnerabilities present by those services and attempt to use them to compromise the target. Open ports. In the same way that unnecessary services present attack options, so do open ports. Software port numbers are used to identify protocols and services and serve as a connection point to a service on a target machine. Port scanners can be used to identify the ports that are open on all machines in a network. An open port means the device is listening on that port number and is willing to make a connection using that port. Unused ports should be shut down. Unmatched legacy systems. Systems that use older or legacy operating systems and applications may lack the security required in today's network. These devices may require special protection, such as placing them in a secure VLAN or installing host-based IPSs. Even modern operating systems and applications will not be secure if they are not maintained by applying updates and security patches as they are released. A formal and preferably automated process should be set up to ensure that this maintenance is ongoing. So I'm going to leave it here today for this video. If you like listening, please consider sharing and subscribing. Thank you.